So far, all the example above are for x going to infinity. What happens when x going to negative infinity? So be very careful over here. We call that the absolute value of x is equal to x if x is greater than or equal to 0, and is equal to the opposite of x if x is less than 0. Okay, so this side over here, think about this as opposite. So for example, absolute value of negative 5 is equal to positive 5. Positive 5 is opposite of this negative 5 inside. Okay, think about this side here as opposite. Okay, so when x is less than 0, okay, remember this means positive square root. Positive square root of x squared is going to be equal to the absolute value of x. Remember the result here has to be positive, right? This is a positive square root. So we put the absolute value over here. And when x is less than 0, absolute value of x is equal to opposite of x. Let me emphasize on this one. That means opposite of. Okay. Now, if you multiply by negative 1 here and also here, you will get negative square root of x squared is equal to positive x over here. And that's when x is less than 0, when x is negative. Okay. For example, let's try to plug in the number just so that you can see how it behaves. So for example, when x equal to negative 5, so I'm going to substitute this x to be this negative 5 here. So negative square root of parenthesis negative 5 squared, that's equal to negative square root of 25, and that's equal to negative 5. Now you see here, this is the x over here. This is the x over here. So you have negative square root of x squared is equal to x when x is negative. So it might take you a while to think about it. Okay, just sit down and think about it. Look at this example and think about it. Okay, now in this example, x is going to negative infinity. So we have to be careful when x is going to negative infinity. Okay, so we're taking the limit of this quotient. Again, we use the same trick in the book. So we're going to divide up and down by the highest power of x in the denominator, which is x to the first power. So we're going to divide by x to the first power up and down. Now this numerator here, divide by x. Now notice that x is going to negative infinity. So eventually x is going to be negative. Okay, so you can think about this x here as negative. So when x is negative, x is equal to negative square root of x squared. So we just go over this, right? So x here is going to replace by negative square root of x squared because of this. Now you can keep this negative sign outside the square root and then bring this x squared inside the square root. Now dividing over here, then you get inside the square root, you get 2 plus 1 over x squared, but don't forget you have this negative sign in front. Okay, so that's what happened when you have this divide by x in the numerator. So you got this, okay, right here. The denominator is just the same as before. 3x divided by x is 3. Negative 5 divided by that is, oh, I think I make a mistake. This is negative 5 divided by x is negative 5 over x. Okay. So what happened over here is when x going to negative infinity, according to theorem A, this part here goes to 0. This is 5 times 1 over x. 1 over x go to 0. So 5 times that also go to 0. So this part here go to 0. So this limit over here go to negative square root of 2 over 3. So it had this negative sign in front. So if you use our shortcut, so probably you will kind of forget about this negative sign. So be careful when x going to negative infinity. And